Okay, another SAT 1 questions. I know that the figure might not be that clear. I will read the question. Also, I have a handwriting other 2 questions, and the one who sent me these questions, he sent me 4, but the 4th question is not clear at all, and there's many things missing, so I can't solve it. So a cube has 2 faces painting black. We have a cube, right? We all know the cube. We all know what is the cube, right? The cube has, right, 2 faces painting black, and the other remaining faces means how many? How many faces the cube has? The cube has 6 faces, right? Uh, the remaining faces painted white. The total area of the white faces, if we find the area of the 4 faces, let's say those 2 faces up and down are black faces, one black and the other down is black. The others, the walls, let's say it's a room, the ceiling and the floor are black, and the 4 walls, the area of these 4 walls, 4 cubes, sorry, squares, right? Squares is 64 square inches. What is the volume of the cube in square inches? If we have already the area of 4 squares, so what is the area of 1 square? One face, 1 square face, right? The area of 1 square face is 64 divided by 4, which is 16. If the area is 16, how much is one side? We know the area of the square is side square. If side square is 16, then the one side is 1 square is 1 inch, right? 1 inch. 1, it's not 1, sorry, it's 4 inch, right? The area of one side is 4 inch. Side times side, 4 times 4 equals 16. That's great. What is the volume of cube? Volume of cube is equal to side cube, means side times side times side, or side power 3. The answer will be 4 times 4, 16 times 4 is 64, and yes, part A is the correct answer. All right, another number, a 4-digit integer. This is very nice number. A 4-digit integer, w, x, y, z, in which w, x, y, and z each represent a different digit, is formed accordingly to the following rules. Digit x is digit y, w plus digit y plus digit z. Now, digit w is y plus 1. This means y equal w minus 1. And digit z is w minus 5. So I'm trying to find z in terms of w, y in terms of w, in order to find also x in terms of w. All of them will be in terms of w. W will leave at w, y is equal to w minus 1, and z is given as w minus 5. So what is x? X is 3w minus 6. That's nice. What is the 4-digit integer? I need to find this 4-digit integer. All right. First, since x is a digit, then the maximum value it can get is 9, and the minimum value is 0, right? So in this case, I can say that 3w minus 6, which is the value of x, is included between 0 and 9 because it represents the x, right? So if we add 6 to all sides, it will be 6 less than or equal 3w less than or equal 15. Divide by 3 all sides of the inequality, we get 2 less than or equal w less than or equal 5. So the maximum value can w takes should be 5, otherwise x will not be an integer, and the minimum value should be 2. What else we have? We have z. Z is equal to w minus 5. Since z is an integer, then z, the maximum value it can take is 9, and the minimum value it can take is 0. So also w minus 5, which is the value of z, should be included between 0 and 9. Added 5, 5 should be less than or equal w, less than or equal, added 5 to each side of the inequality. It will be 14, right? So w should be less than 14 or equal, greater or equal 5. Between greater or equal 5, less than or equal 5, we have just a common number which is 5. So W should be equal to 5. If we find W, we found them all. W should be equal to 5. This means X equal 3W minus 6, then X equal 15 minus 6 is 9. W is 5, X is 9, Z is W minus 5, so it is 5 minus 5, so Z is equal to 0. And what else? Y is W minus 1, so Y is 5 minus 1, then Y is equal to 4. What integer we have? W, X, Y, Z. We can write it in the form W is 5, X is 9, Y is 4, and Z or Z is 0. So this is the 4-digit number. It's 5,940. Let's go to the third number. Third number is, we have a figure volume, we have a figure of a pyramid of square base of M side. So this is also M, this is also M, and this is also M, because it's a square. And E is the edge. All these vertices of the square, they are all intersect at the edges comes from each vertex of the square. They all intersect at V, and they form the pyramid. H is the height of the pyramid. So this is H. This is H is the height of the pyramid. All right, that's nice. What we have to do here is he wants me to find the value of H. How much is H with respect to M if E equal M? E equal M. The edge is also equal to M. That's really simple. We can start. We can start in a fact that the height of a pyramid is perpendicular to the base, right? And we know that if a line perpendicular to a base in a plane, this means it is perpendicular to every single line in a plane. This means it is perpendicular or orthogonal to any single line. So this one, this height is perpendicular to this side. Let me redraw. The edge comes from this V to this point, and the foot of height and the height. This is the height, and this is the foot of the height, and this is connected in this line, right? So this is 90 because it is perpendicular, right? What else we have in this figure? This diagonal or this diagonal and this diagonal, they intersect, right, at the foot of the height, the foot of perpendicular, because the diagonals, because the length of the edge is E, which is equal to M, so it's the regular pyramid. Regular pyramid, the height goes from the vertex to the meeting point of diagonals of the base. So this means I'm finding the diagonal of the base. Let's take this triangle here. This triangle has what? Has side. This triangle has side with M. Another side is M because it's a square, and this is diagonal. In this case, how much is the diagonal? Diagonal square equal M square plus M square, right? Pythagorean, we can find it directly, which is M radical 2. It's a rule, side radical 2, in case we have right isosceles triangle, or by Pythagorean. So D square is equal to M square. This means D is M radical 2 by making radical to both sides. If the diagonal is D radical 2, we don't need the whole diagonal. We need just this part, which is half of the diagonal. So it's diagonal over 2, which is M radical 2 over 2. And this side is M, and this side is H. Again, we apply Pythagorean, and we got H. I don't know if we have time to do that. So if video stop. Okay, so H square equal M square minus this value to the other side, which is m squared divided by 2, so it's m squared divided by 2. So